day, everyone. Once again, we meet this time to discuss exponential graphs. And thank you so much for joining us. And if you haven't subscribed to our channel, if you are new, welcome. And please consider just clicking on that subscribe button. And for those of you, obviously, who would like to get assisted, whether in mathematics or physical science, please contact us, and our email address is info@mlungisinkosi.co.za. Hey, and don't forget to click on that notification bell as well. So what we want to do today is discuss exponential graphs. Okay, so I'm just going to delve right into it. Hopefully we can make it as easy as possible. So when we look at exponential graphs, so I'm going to start with the basics thereof and then just go into, the ones that are shifted. So essentially what we have is something that looks like this. Y is equals to a to the power x. All right. So this is the basic of the equation of an exponential function. Okay. So a couple of things that we need to note. So when the value of a is greater than 1, so meaning that once a is greater than 1, what we normally have is a graph. Now, please, I want you to note that increases obviously going that way. So this would determine the shape of the graph. But if the value of a is less than 1, okay, and of course it should be greater than 0 in this case, then we know that the translation, or in this case our graph, would actually be decreasing, and this would be the shape that goes along that direction. Okay, so now a couple of things that we also need to know. Remember, for exponents, any time that you've got anything to the power 0, okay, so if I've got a to the power 0, remember anything to the power 0 gives us 1. And so that is why for the basic graph, I hope this color is not an issue. Okay, so that's why for the basic graph, say for argument's sake, we get y is equals to 2 to the power x. All right, what will that graph look like? Okay, that graph will just simply be, now remember, it should always cross whenever we've got 2 to the power 0, okay, that is equal to 1. So meaning that in our graph, anywhere where x is 0, that is in this case where x is 0, we know that y will be equal to 1. So our graph should cross there. You can see there that my base is 2. It's definitely greater than 1. So the shape of our graph would look more or less like that. Okay, that's what our exponential graph would look like. Now, just one other thing. So it means that for the exponential graph, now I'm not going to go into much of the pedantic details. I just want to get to the examples as quickly as we possibly can. So for the exponential graph, what we want to do is, I want you to please note that obviously now the y-axis, okay, rather the x-axis rather, now act as your asymptote, and you can obviously guess why. Okay, because in this case we cannot actually have the negative y. It doesn't matter what you do. So the horizontal asymptote in this case would become y is equal to, or rather, I said horizontal asymptote, but I'm writing y. It becomes x is equal to 0. Okay, so in this case it means that for our horizontal asymptote we've got x is equal to 0. So it means that the graph will never cross that line. Okay, right, now just a couple of things to note there. If we were to have a translation, maybe before I get even to that, okay, I want us to look at what the graph looks like when it's shifted, and I'm just going to make some comments about that. So in this case, the equation can change as follows. We can have y is equals to a into x minus p plus q. And please, I want you to note what that simply means. It would be the same graph that we had, okay, the one that we drew there. But what is the difference? It means that we are shifting. Now, please, I want you to note this. When p, the value of p is greater than 0, okay, so in this case, when p is greater than 0, it means that we are shifting. Now, please, I want you to note, it's x minus p, right? So it's x minus p. When p is greater than 0, it means that we are shifting our graph to the right. Okay? And of course, when p is less than 0, it means that we are shifting our graph to the left. Okay? So that means if we've got, in our previous example, suppose we have y is equal to 2x minus 1. Note that we already had a negative sign for p in the place of p there. So it's x minus 1. So what would this translate to? It means that we are taking the very same graph and we are now shifting it to the right, in this case, by 1 unit. Okay? So whatever happened at 0 would now happen at x is equals to 1. Okay? Right. Now, for q, on the other hand, okay, so this is what we would call, sorry, for p, let's go for p first when we're talking about shifting to the right and to the left. When p is greater than 0, we said we are shifting to the right, okay? So that means that this is what we call a horizontal shift. And obviously shifting to the left or to the right. Now, when q, this value over here, all right, I'm just going to circle it with a green. So when q is greater than 0, in this case, then what are we doing? We are taking the same graph and we are shifting upwards or downwards, right? But in this case, when q is greater than 0, it's an upward shift, okay? And again, when q is less than 0, okay, so it's a downward shift. All right, so what I would like to get to ultimately is that we should get to a point where we can do some examples on this. Okay, what else do I need to mention in terms of this graph? Okay, so we can find x-intercepts and y-intercepts. We'll get into that. I think I want to mention that once I've got my examples. Yeah, I think let's just dive right into an example and see how to apply when it comes to the exponential graph. All right, so now we are going to look at just how to draw the graph, and I don't want this video to be too long. Let's just get straight to the point, okay? Of course, you know, we could have had just a situation where we don't have shifts, but I want to include them now because, you know, the other graphs can be quite straightforward and simple. Right, so now they say draw the graph of f of x if f of x is 2x, 2 to the power x plus 1 minus 1. So the first thing that we're going to do is let's note what they've done. They've taken a graph, our base is 2, okay, so meaning that when we know that our base is 2 in this particular case, then we know that we are going to have a graph that increases as you move towards the right. But what have they done? They have shifted. Now let me just use another color. All right, they have shifted it, okay? In this case, we've shifted the graph to the left. So when we see a positive there, it means we have shifted it to the left by 1 unit, okay? So if you had a graph of 2 to the power x, we've taken the graph of 2 to the power x and we've shifted it to the left by 1 unit. But we've also taken that graph and we've shifted it. Now note this minus 1. It means we have shifted it down by also 1 unit. Okay, so now remember, as opposed to having the graph being, okay, so if it was just a normal graph, it would look something like that. We know that x is equals to 0 would be our horizontal asymptote, okay, that line over there. Okay, let me make it red. So that line would be a horizontal asymptote. Now, it's no longer going to be a horizontal asymptote, but instead, let me just choose the yellow color, right? Instead, -1 is going to be our asymptote because of that vertical shift. It's been shifted vertically by 1 unit, so we've shifted it down by 1 unit. So what is going to be our asymptote in this case? We start with our asymptote. So our asymptote is going to be at x, actually y. Yeah, this thing can show you proper flames, eh? So that's going to be at y is equal to, all right, our pen is not behaving again. So this is going to be y is equal to -1. Okay, so this is where our horizontal asymptote lies. Now, secondly, let's do this. Let's find the x-intercept and the y-intercept. Now, please remember, I haven't drawn the graph as yet. I was just illustrating something there. So let's find the x-intercept first. Okay, now remember what happens at the x-intercept. We know that y is equals to 0. So it means that I'm going to take that graph, okay, and say 2 to the power x plus 1 minus 1 should be equal to 0. Okay, so let's try and solve for that. So this is going to be 2x plus 1 minus or rather is equal to 1. So what we do when we are dealing with exponents, and of course we're going to get to a time when we just deal with exponents, I know, because we're trying to cater for metrics at the moment, but we'll get to that time where we deal with exponents. So what we do, we try to get the basis to be the same. So in this case, I've got 2x plus 1. In this case, I can say 2 to the power 0. Remember, anything to the power 0 is equal to 1. So as a result, if my bases are the same, I can drop down the exponents. So in this case, it's x plus 1 is equal to 0, and therefore it means that x is -1. So remember, what this simply means is that our graph is going to cut through the point -1 and 0, okay? And then we find the y-intercept, okay? So we find the y-intercept, okay? Remember what happens at the y-intercept. We know that x is equal to 0. So it means that we're going to take our f of 0. Everywhere we see x, we are going to substitute with 0. So remember, so this is going to be 2 to the 0 plus 1, okay, minus 1. So what do we actually have? We have 2 to the power 1 minus 1. And remember, 2 to the power 1 is 2. And as a result, that remains 2. That remains 1. Oof, what happens to my maths? Okay, so that becomes 1. Okay, right. So it means that our graph is also going to cut through the points where x is 0 and y is 1. Right, so what does this translate to? Let's try and draw our graph, okay? So there's our graph there, okay? These are my axes, okay? So in this case, what we are going to do is, we know that our graph is going to cut through, or first of all, let me draw the asymptote, okay? We said we're going to have an asymptote. Let me make it nice and bright, okay? We said we're going to have an asymptote at y is -1. So our graph will not cross this line. And then secondly, our points in this case, we are going to have a graph that cuts through -1 and 0. Okay, so where x is -1 and y is 0. Okay, so let me make that nice and red. Okay, and then we are also going to cut through the point where x is 0 and y is 1. Okay, instead of making that red, I actually took off the right. So there's our graph. In fact, let me just choose another color. Okay, I want something which is a little bit brighter. Okay, so our graph would look something like this. Okay, so we know it would never cut through in this case, so that's our x and that's our y, and in this case that would be our graph. Okay, right, so I hope that makes it quite simple in terms of the exponential graph. Now just a couple of things. I know I haven't spoken much about this because I wanted to treat it more or less separately. But I am going to actually treat it at a point because I want us to talk about reflections and symmetry, but we will actually treat that separately. However, for the exponential graph, let me just get ahead of myself a little bit, and then I'll just come back and obviously add more detail. So if in this case, suppose I had a graph, let's say y is equals to 2x, okay? Remember, in this case where I now want to have a translation, now what would this graph look like? It would be a graph, remember we said it would be a graph that looks like that, and I know it would cut through 0 and 1, okay, where x is 0 and y is 1. Now, what would happen if I wanted to draw a graph? Okay, y is equal to 2 to the minus x. Do you see what I've done? I've actually made now, translated this graph. So instead of having positive x, I have now a negative x. Now, please, I want you to note, once I do that, okay, what happens is that it becomes a graph that is now, so 2 to the minus x is the same as saying 2 to the minus 1 to the power x, and which is the same as 1 over 2 to the power x. So what we've in fact done, you see now I've actually taken away space for myself. Okay, so what we've actually done is that if you remember what we said earlier on, that when the base is actually between 0 and 1, what simply happens? It means that the graph is actually going to be decreasing as you go that direction. So once I make once I change the sign of the x, in this case, it becomes a graph that is mirrored around the y-axis. Just remember that, right? It is now mirrored around the y-axis. So it means that in this case, it's reflected about these y-axes. And then secondly, what if I wanted to draw a graph, okay, that is y is equals to minus 2 to the power x? What would be the difference? So if this again is our original graph, this is what it would look like. What would be the graph of minus 2 to the power x look like? Okay, so this would be a graph that is mirrored in this case about the line y is equal to 0. So it's mirrored about in fact not the x-axis. It's mirrored about the x-axis, sorry about that. So it's mirrored about the x-axis. So in this case, you'd have a graph that looks like that. Okay, so we will consider that for the future. All right, I want to kind of leave it there when it comes to this graph. As I said, what I'll do at the end is that we'll consolidate all the graphs and look at past exam questions where we've got all the graphs kind of mixed up together, and of course we'll treat some questions that are exam related. Okay, right, for now I want to leave it here when it comes to the exponential graphs. I will see you guys again next time. Please make sure to subscribe. Please just tell as many people as you can about this channel. Share. Okay, and please don't forget to also click on that notification bell, to kind of remind yourself every time we're posting a lesson. Then you'll know and jump into it, because we're all about good content. Otherwise, from me for now, I'll see you guys next time. Sharp.